is Muhammad Zahin Pasha, metric number A18KE9007. I'm from group number 2, and I'm here to introduce you to magnetic levitation and types of magnetic levitation. So what is magnetic levitation? Anything which may levitate by means of a magnetic power is simply called magnetic levitation. The most common use of this technology can be seen on maglev trains. The technologies used in maglev trains is of two types: electromagnetic suspension and electrodynamic suspension. Electromagnetic suspension is levitation that takes place by attraction. Attraction is caused by currents within each of the circuits traveling in the same direction. This attractive force is created by the train and the track.
Hello, this is Nain Mubarak, and I'm going to talk about the fundamental of magnetic levitation. Magnetic levitation or magnetic suspension is a method where an object is suspended with no support other than magnetic fields. So to understand about that, let's go to working principle. Working principle is basically about the fundamental of the magnetic field lines. So when we have two different poles, they will attract each other. Whereas if we have two similar types of poles, they will repel each other. So this is actually the basic idea behind the magnetic levitation. Let's see an example to elaborate more about that. Here's an example of using two similar poles to produce repulsion force. And in this example, we use different types of poles to attract and pull the train forward in this example. So as you see here, this object is hanged because the upward repulsion force is balanced with the downward force of the gravity, and at this point the equilibrium is achieved where the total force is equal to 0. This force called the lifting force. So that's all about the fundamental and working principle of magnetic levitation.
Hi there, I am Malik. After the maglev has been introduced and defined previously, I will just dive into the application of the magnetic levitation, starting by maglev train, going to the wind turbine, and last but not least, space propulsion. What is maglev train? Simply is a system of train transportation that uses two sets of magnets, one set to repel and push the train up on the track, and the second magnet used to move the elevated train forward. The maglev train has to go through some functions to operate in a high speed. The first one, levitation, which is rising the train on the track. Second, the propulsion used to push the train forward. And last is lateral guidance. This is to keep the train in the center. These are some pictures to give illustration on that point. The first one is shows the lateral guidance where the train at the center, and the second one shows the direction of the train. There are many types of maglev train, but in this video we are going to introduce two. The first one, electromagnetic suspension, where electromagnets attach it to the train and has the ferromagnetic stator on the track that used to levitate the train. And also the technology basically take place here where a computer used to change the amount of current to keep the train in a standard distance, which is 1 centimeter from the track. And also a battery used as a power supply. Going to the second type, which is electrodynamic suspension, where superconducting under the train used to levitate the train about 10 centimeter, and also the force in the track basically is created by induced magnetic field in wires. And also this type of maglev train basically needs retractable wheel especially at the low speed. Going to the most interesting part, which is pros and cons. Starting by the electromagnetic suspension, where low magnetic fields inside and outside the vehicle, considered as a quite cheaper where commercially available. Going to the electrodynamic suspension, where a highest speed about 581 km per hour, and also a heavy load capacity. Going to the disadvantages of these two systems, starting by the system needs to be monitored by an outside system to maintain the distance between the train and the track. The second one is vibration may occur due to the instability and outside monitor. Last is the disadvantages of the electrodynamic suspension, where must be used or must use magnetic shielding due to the strong magnetic fields, where the last disadvantage is the train must be wheeled, especially at low speed.
Assalamu alaikum, this is Hisham Ali Gladys, and I'm going to speak about another application that is related to magnetic levitation. And this application or system is one of the most efficient systems that is related to magnetic levitation, which is wind turbine. So let's see how does it work. The vertically oriented blades of the wind turbine will be suspended on the air above the base of the machine, replacing the need for ball bearings. And the wind turbine uses a full permanent magnet instead of using the electromagnets. Therefore, it doesn't require an electricity to run the system. And that will help also to reduce the maintenance costs and increase the lifespan of the generator.
Hello everyone, I'm Fitra Hanifa from the group 2. I want to share about the magnetic levitation, or we call it as maglev propulsion, the force that drives the train forward by using the linear motor. This is the concept. This is the conversion of a railway pantograph on board electrical equipment. This is synchronous motor, so this is wheel split one and spread out. The inside one is for magnetic one into this side, and for the sidewall of guideway from the outside of the synchronous motor, it will be placed beside the sidewall of guideway. The light's powerful onboard superconducting magnets create a magnetic field to align an electrical motor. For the ground side, this is a propulsion coils that act like an electric motor armature are mounted in a continuous line on the guideway. And this is for the transformer station or transformer inverters. Principle is in normal conducting high speed or service transport HSST maglev, the motor has been split, open and flattened. For the first is for the primary side coils attached to the car body, and for secondary side reaction pads installed along the guideway. The components ensure both propulsion, braking force without any contact between core and guideway, and for induction motors. And this is some inherent limitation. Principle of HSST magnetic propulsion. This is a rotary motor and linear motor. For rotary motor, there's a stator and rotor. For stator is including primary, we call it as primary coil, and for the rotor is aluminum cylinder inside. Then for linear motor, this is primary coil, the same as rotary. This is for stator, but it's primary coil inside the train, and for the outside train, this is a secondary reaction plate. So for some inherent limitation, greater size and weight of onboard equipment, and difficulty in collecting electric power, and reduced addition between wheels and rails at higher speeds because of wheel slip. This is a linear motor, rotary motor, unrolling rotary motor, and linear motor. For rotor, inside rotary motor, it's shaped like a cylinder, and for this one is like U shape for unrolling rotary motor. So for linear motor, only the rotor should be moving. Next is one of linear motor, linear induction motor. The special one is for the conducting sheet. And the other one for translator or brake iron and stator windings is same as other. Next, linear switch reluctance motor. This is for translator, and in translator it's some kind of difference between translator this one, there's no gear, or maybe it's will caused by the conducting sheets, but the gear cannot touch the stator windings. It is same as before for stator windings and stator. And the next one is linear synchronous motor. The special one is permanent magnets. So for stator windings, it will be caused. There's a gap between stator windings and translator by permanent magnets. Before this, we're using a conducting sheet, but here we're using as permanent magnets. So the last one, direct current linear motor. This is the design of tubular DC linear motor. So there are armature supply, armature windings, armature brush, armature core, insulating space, cylindrical outer shell, and flattened pole shoe and fail winding.
Assalamu alaikum, this is Khalid Ahmed Khalil. I'm going to sum up the topic of the magnetic levitation. The name maglev is derived from magnetic levitation. Magnetic levitation is a highly advanced technology. It has various uses, including clean energy, like small and huge wind turbines at home, offices, and industry. Also, building facilities, transportation system, of course, magnetically levitated trains, personal rapid transit, etc. Also, it is included in the weapons like guns, rocketry, and in the nuclear engineering, in the centrifuge of the nuclear reactor. Also, it's used in the elevators, advertisement, and toys like trains levitating, spacemen. Also, it's used in stationary pens. We can mention more maglev applications like analyzing food and beverage. The scientists describe development of a special sensor that use maglev to meet those needs. Also, we can mention the complicated maglev heart pump, which is very complicated and more efficient than the blood heart pump. What we can say about the future of the maglev systems, the common point in these all applications is the lack of the content, and thus no wear and frictions. This increase efficiency and reduce maintenance costs, and increase the useful life of the system. The magnetic levitation technology can be used as an efficient technology in the various industries. There are already many countries that are attracted to the maglev systems. Many systems have been proposed in different parts of the world. To sum up everything, this video presentation tried to study the most important uses of the magnetic levitation technology. The results clearly showed that the maglev can be conventionally considered as a solution for the future engineering needs of the world. Thank you for listening. I hope this video presentation was useful and purposeful. I'm leaving you with the reference. Thank you.